This video is to help you with the homework from section 1.1.4. The homework problems are 128 through 132. So for 128, they are giving you a table showing you data for winter temperatures in Urbana, Illinois from 1990 through 2009. So the first thing they want you to do is just create a question that you could answer by using all of the data. So your question could be different from someone else's and still be absolutely fine. So for example, maybe you would ask, what is the average of the temperatures between 1990 and 2009? Maybe, and then you could find that. Maybe you could ask the question, what is the difference in the highest and lowest temperatures between 1990 and 2009? And you could answer that. Or you could ask, what is the highest temperature between 1990 and 2009? For B, they want you to create a question that could be answered by just using some of the data. So maybe you would say, from 1990 to 1999, what is the average temperature? Or what is the median? Or what is the difference between the highest and the lowest? So the difference between A and B is that A wants you to look at all of the data, and B wants you to only look at some of the data. Again, you're creating the question and finding the answer. And then for C, how could you organize the data to answer your question? So, if you were going to look at finding the median, you'd want to put the numbers in order from least to greatest. If you were looking at, averaging them, you'd want to look at adding them and then, dividing by how many values there were. So just, how you would organize this to answer your questions is what they're getting at for C. For 129, you're looking at this histogram, which shows the amount of snowfall in Urbana, Illinois during winters from 1990 to 2009. So what they're saying is, between 0 and 5 inches of snowfall happened in 1 year. Okay. Between 5 and 10 inches happened in 5 years. Between 10 and 15 inches happened over 2 years. Okay, so that's what you're looking at and reading. So when it says what range of snowfall measurements occurred the most often, they're saying basically what range, 0 to 5, 5 to 10, 10 to 15, 15 to 20, and so on, which one occurred the most. All right. And then were there any years where you had unusually high or low snowfall amounts? And then lastly, half of the years had snowfall amounts above how many inches? So, this one will be one where you have to kind of do a little bit of approximating, because if you look at the total number of years, all right, and then you look at what's the halfway point there, you're going to have to approximate how many inches of snowfall will be above that by looking at the table. For 130, they want you to copy the number patterns below and then write the next 4 numbers in the pattern. And then lastly, describe the pattern in words. So you're looking at, what occurs to get you from the first term to the second to the third, and so forth. Now, most people have difficulty with B and C, so I will give you a little bit of help with those. One way to look at B, and it's not the only way, but is to look at it as though these are square terms, which they are. They're all perfect squares, we call them. The reason they're all perfect squares is because a perfect square is a number that if you wanted to create a square, it would have that area. In other words, a square with a length and width of 1 will have an area of 1. A square with a length and width of 2 would have an area of 4. A square with a length and width of 3 would have an area of 9. So because these numbers can be the area of squares, we call them perfect squares. So that might help you to figure out the remaining numbers. Again, there's another way to view that pattern as well that will still give you the same numbers. And then for C, what you want to do is look at the previous 2 numbers. So 1, 1 giving you 2. And then 1, 2 giving you 3. And then 2, 3 giving you 5. So those are my hints to you on 130, B, and C. For 131, you're going to round the number to the specified place, and then you're going to go ahead and round it. So I'll just go ahead and do one as an example for you. So let's look at D. We have the number 492 and 3,069 ten thousandths. Okay. We know we read it that way because 492, when we see a decimal, we read the and. We read 3,069 as one number. We look at what place value is the last digit in, and that is the 10 thousandths. Tens, hundredths, thousandths, 10 thousandths. We read this number as 492 and 3,069 ten thousandths. Then when we want to round it, we look at what place value we're looking to round, which is the thousandths place. So the thousandths place is right here. What I suggest you do is underline the place value that you're looking at. And then I like to do an arrow to the value to the right of that. So the place value we're rounding to is the thousandths. The place value behind that is what I sometimes call the indicator number, meaning it indicates, do we round up or do we round down? Once the indicator number has done its job and has told us if we round up or round down, it becomes a 0, as well as all the digits behind it become zeros. You can also, if that number is behind a decimal point like this, have that number become a 0 or simply drop off. So looking at this example, we would say the 492 stays as it is. So does the 3 and the 0. And so what we're looking is, what is going to happen to the 6? Well, the 6 is the place value we're looking to round, and behind that is a 9. If that indicator number is 5 or more, you round up, meaning the number that's being rounded goes up to the next value. If the indicator number is 4 or less, you round down, and rounding down means that the number in that place value simply stays as is. So the indicator number is a 9, which tells us to round up. So the 6 becomes a 7. If that value behind the 6, like I said, had been 4 or below, we'd have left the 6 alone. That's the idea of rounding down. Now, once we have done our rounding, then as I said, the 9 has done its job, the indicator number has done its job, it told us to round up, then it and anything behind it becomes zeros, or as I said, if it's a situation like this where it's behind the decimal point and doesn't have a value as a 0, it can just be dropped off. All right, so that's what you're doing with your indicator number. Now, I will do one additional example to you from this one, and let's look at B. So B wants us to take 45,469 and 2300ths and round it to the thousandths place. So again, I'm just going to go ahead and write the number down first, 45,469 and 2300ths. And we're going to underline the place value that they want us to round, which is thousands. Notice it does not have a TH. It's not thousandths like D, it's thousand. So the thousand spot is right here. And the number to the right of that, the indicator number, is the 4. So the 4 in the 10,000ths place will stay. And then we have to decide what we're going to do with the number in the thousandths place, which is the 5. Well, the indicator number behind it is a 4. And if it's 4 or less, it tells us to round down, which means we leave the 5 a 5. All right, rounding down means that we simply leave it alone. So now the indicator number, the 4, has done its job. So it and everything behind it becomes zeros. Okay, so we could do our answer like that. Or since some of those are zeros behind a decimal point and don't have a real purpose anymore, then we could also just make it 45,000. So those are a couple examples for you for 131. For 132, they are showing you a graph that shows how far Ben is from home during a typical school day. So at 7 a.m. he's at home, and then he starts going away from home. By about 8, it looks like then he's about 2 miles from home. Then he stays at that location for a little while, and then by about 8:30 he starts going further away from home till about 9 o'clock. He's 4 miles from home. He stays there until looks like maybe about 2:30, and then he starts heading straight back till he gets all the way back to the house. So based on that, they want you to answer some questions. What do you think he was doing between 7 and 8? So what would make sense to indicate why he ends up going from being at home to about 2 miles away from home? Then what do you think he was doing between 9 and 2:30 during this stretch? What would make sense on a school day for why he is staying at the same location, about 4 miles away from home? And what time did he leave at the end of the day to return to his starting point? Right, so those are the homework problems. Hopefully these hints will help you out. Thank you.